students actually have problems understanding about finding the perpendicular distance of another plane to each plane. Now, first thing first is usually when the question asks you for this kind, number one, the two planes will always be parallel to each other, okay? Because the perpendicular distance from each plane to P is, okay, square root 41. Now, there are actually two planes. So first, I have this P, which is r dot 1, negative 2, negative 6 equals to 32. This is in r dot n equals to d form. So the second thing is when I want to find the displacement. Displacement means that the positive and the negative matters. From my plane to O, okay, the formula is actually called r dot n hat equals to displacement, or rather big D, which is called displacement. Okay, big D, and D is the displacement from the plane to the origin. And how do I get n hat from r dot n? I need to divide by the magnitude of n, right? Yeah, so in a way, r dot n hat is the same as your D, which is the 32, over magnitude of n. Okay, D over magnitude of n, which is 32 over the magnitude of the normal, 1, negative 2, negative 6, and you are going to get 32 over square root 41. Alright, so it means that P is 32 over square root 41 away from O. There is O here, there is P here, which is over here is 32 over square root 41. That's the distance. The question is asking for an equation of another plane. Let's say this is the red plane, okay? And I'm going to call this P1. P1 is square root 41 away from P. So, what can you tell me about the total displacement of P1 to the origin? The total displacement of P1 is going to be 32 over square root 41 plus square root 41. Wow, very hard to add this in. Let's rationalize the 32 over square root 41. Okay, I multiply by root 41, I'll get this. Okay, treat the root 41 as like an x, I'm going to get like 72 over 41 times of root 41. Okay, so that's the displacement of P1 to O. Okay, and that is also the d over magnitude of n of d1, or rather, so of P1. So I put it as d1 over magnitude of n is equals to 72 over square root 40 over 41 times of square root 41. What is the magnitude of n? Since they are parallel, right? Yeah, the magnitude of n is going to be square root 41 because it comes from the normal. Okay, equals to 72 over 41 square root 41. Cross multiply, you get d1 equals to 72. So what is the equation of P1? R dot, the normal is going to be the same because they will always be parallel. These two planes will always be parallel. Minus 2 minus 6 equals to, what's the d1? 72. How to find the other one? The other possibility is that this plane could be below the origin. I label this as P2. Okay, P is fixed. P is over here, which is 32 over 41 away, root 41 away from O. But the other one from here to here is root 41. Okay, so what is the displacement? If you draw, you can see obviously what is the displacement. What is the displacement of P2 from O? That will be equals to square root 41 minus 32 over 41 times of square root 41. Treat the square root 41 as one whole, as an x, then you use one whole 41, so that will be 9 over 41 times of square root 41. But this plane is below the origin, so I need to put a negative sign and I need to put a negative sign. Okay, using the same method, d2 over square root 41, which is the magnitude of n, is equals to negative 9 over 41 square root 41. Cross multiply the square root 41 over, d2 equals to 9, negative 9. So the second plane is r dot 1, negative 2, negative 6 equals to -9. Okay, and this is how I find the perpendicular. I find the new Cartesian equation of these two planes that could one be above the original P and the other one could be below. Okay, all your planes equation are in the form of r dot n equals to d. If you take the d and divide by the magnitude of n, you are going to get the displacement. Displacement means how far is the plane away from O. It could be in the positive direction or it could be in the negative direction.